Elnappa, what is no answer? What is no answer for me? How was the yesterday's class? Interesting. Good. Yes, interesting. So how water moves from cell to cell, organ to organ, plant to plant, soil to plant. So these things we have to study. Maybe our lecturers, they have taken already the practical session, osmosis and all. So a little theory part to be covered today. Okay. So I wanted to give some few points on osmosis, diffusion, and then imbibition, and then plasmolysis. So all these four sections, I wanted to give you introduction and how it happens, and when and what are the advantages of this for water movement process, and what is the importance of water and how it behaves. Okay, so shall we start the class today?
Okay, sir.
Yeah, we will be attentive. I will ask a few questions on the lectures while going on. We have already studied in the practical, but some theoretical aspects we have to cover. Okay, so this may be the end class of this semester, I suppose. Next week, I don't know. We will see. Okay. Yeah. Okay. Are you seeing these slides?
Yes.
Yeah. So it went down. Okay. So now we are going to study water movement. So how the water, what is the importance of water, and what the water is doing. Okay, you will see one by one that it is the most required material, in the plants. Okay, in human beings, how many percent? 80%. 80 to 90% of water. Like that, the plant also, it requires a large amount of water is required for plant. And not only that, it available throughout the plant body, from the root to the leaf, stem, flower, seeds, everywhere the water is available. Okay? Then, it is, when you consider the number of molecules in a plant, water has more number of molecules in a plant. Okay? So, when you weigh any plant, the 90% of the fresh weight has water. That means, if you take 100 grams of amaranthus, when you dry amaranthus or whatever it is, when you dry, the dry matter will be around 90 or 10 grams. That means all 90 is water. But sometimes in a very growing cell, it is more than 95%. But the seeds and the dried roots and dried products of plants may have a very few amount, that is less than 10% or maybe 5%. Okay, so that entire plant has the molecules of water. So the water is a very much important item for plant growth. So then it is a very important in plants. Therefore, it carries certain functions. So it is a major constituent of protoplasm. In any cell, you know the protoplasm, you know the structure of the protoplasm, you know how to, yeah. Yeah, in a cell. Yeah. Please, Professor. Yeah, no problem. In a cell, major constitution of protoplasm. Protoplasm, you know, I will show you the picture in later slides. The protoplasm, major constitution is water. Okay? So from that water only, the all constitutions are transported. All nutrients, minerals are transported with the water. So the nitrogen, phosphorus, potash, all nutritional subjects are transported from one part to another in a cell. Also takes place through the water in a protoplasm. Cell to cell, tissue to tissue, organ to organ. So when it transfers those constituents, materials or solids, the water helps to transport. Okay? Then it is a medium where all the metabolic activities are happening. We have to have a medium. No? In the medium, we have to have water. Then only the metabolic activities are taking place. Not only that, to take metabolic activities, water is necessary. So that in the protoplasm, all metabolic activities are taking place in the medium. Also, in metabolic process, water is also necessary. Example, photosynthesis. Photosynthesis, water is necessary. Okay, the transpiration process, water is necessary. So therefore, the water plays a major role in this one. So I have given. In the second point, in a cell, it should have some form. It should have some form. Maybe plant cell. It should have a form. To form that shape, we should have turgidity. I will come what is turgidity special form. So then, during the elongation phase of a cell, water is necessary. Okay? And then, even to gain or loss from the plant, it is also taking place through water. For example, if you don't have water, the nutrients will not come. If you don't have water, the photosynthesis will not occur. So it is a very important role it takes place. Okay? Then, now we will see what is the nature of water within the cell. If anything within the cell, we will call cellular organs, cellular water, cellular constituents. So then, whatever the availability in the water, the cell, we call cell, within the cell. So cellular water. Now I want to see what is the characters, or what is the nature of cellular water. Okay? So see, we will see the large fraction of water in plant cells is free and mobile. So to be free and mobile, the cellular water also should be free to move. So therefore, it is captured in a vacuum. In a vacuum. So if you fill balloon with water and tie it and throw it, so it goes like that. So vacuum. Vacuum has, in a protoplasm, in a vacuum, that has this cellular water. Okay? So it goes into several parts. So, and then a small fraction of water is sealed firmly with a plant cell with hydrogen bond. In a plant cell, I have already told you that cohesion and adhesive. So these forces, cohesion forces and adhesive forces, are taken by the hydrogen bond in the cellular. Okay? Then all membrane, they have water molecules, hydrophilic, hydrophobic molecules. Example, endoplasmic reticulum, mitochondria, chloroplast, tonoplast, and plasma membrane all have this particular water, the cellular water, it is a constitution. Even the protein interface, that is captured by some portion of water. So, in general, cellular water has high density. So if it does not have high density, the movement of water will not take place. I will teach you how it moves because of this various density difference. So these are three major things we are going to see today: diffusion, osmosis, and imbibition. Okay, up to now, are you clear? Hello?
Yes, sir.
Up to now, what we have seen? What we have seen up to now? Yeah, can anyone say, please? What we have seen? Hello? Yeah, anyone say? Tell me, open your mouth. What we have seen? Function of water and the importance of water, and what is the nature of cellular water. Okay, can anyone say? What are these three?
Function of water, importance of water.
Then, nature of cellular water. Okay. Now, how this water moves, we will see one by one. Okay. Three major constitutions we have seen: process, diffusion, osmosis, and imbibition. What do you mean by diffusion? Can anyone say? What do you mean by diffusion? I will keep silence until all your mouth. Have you studied diffusion earlier?
So it's the movement of substances from high concentration to a low concentration?
Very good. Any particle, it moves from its high concentration to its low concentration point. That is diffusion. So even osmosis or imbibition, whatever it is, takes place through diffusion. The water movement from one place to the other, we call diffusion. So in these three phenomena, we have to see. So this is called water movement through diffusion, through osmosis, or inhibition. So now we will see one by one. If you have any clarification, please raise your hand and take me. So this is diffusion pressure. So if molecules are there, okay, several molecules are there. This molecule wanted to move here means there should be some pressure to activate the molecules to move from one place to the other. That means there is a pressure potential difference. Here the more molecules are there, here the less molecules are there. So then it will come from one place to the pressure is there. Okay, if it is high diffusion pressure, diffusion takes place more. If it is a less diffusion pressure, then the diffusion takes place less. So whatever it is, there is a gradient, pressure gradient, that is diffusion pressure gradient. Okay. So if the diffusion pressure gradient steeper, diffusion increase. That means there are some molecules. Okay, example, we will see that the potassium permanganate in the water, when you drop one potassium permanganate, then it will try to disperse through the beaker. Have you seen that? Have you done in the experiment? Hello? Have you done? Please answer my questions, I say. Have you done this potassium permanganate diffusion experiment?
No, sir.
Then you must say no. Please answer. Little. So then we will, if the charts comes, we will do it once you physical lecture starts. I will make you see this potassium permanganate, how it moves from one place to the other. So it starts to move. Then if you put more potassium permanganate to that particular point, then it quickly moves from one place to the other. Why? It is the diffusion pressure we are increasing. So when the diffusion pressure or the pressure gradient is steeper, longer, or big, diffusion increase. Then temperature. In general, temperature, what will do the temperature with the molecules we have studied in the A level, in physical chemistry, physical chemistry. That why that water molecules or gas molecules will actively move. Why? Because of the energy, temperature. When you take temperature more, okay, that actively it moves from one place, it activated. So in general, temperature increases the pressure, okay. Then density of the diffusing particle is less. That means if we in a place diffusion particle is less, more particles try to come into here. Okay, so when the diffusion particle is less, the diffuse takes place increasingly. Okay, and in a medium, if the diffusion particles concentration is more, it may not move because already filled. Okay, so if it is less concentration, the diffusion is more. So what are the how the diffusion can be increased? Can anyone read this? What is the problem of reading? Hello? Hello? What is the problem of reading? Are you sleeping? We all are sleeping. Can you read? Read it. If yeah, okay, that's enough. Somebody, next one. 05, 005. You read.
Yes, sir.
You read it.
If the temperature is increased.
Okay. 0010. Read the third one. 10.
The density of the diffusion particle is lesser.
Yeah, then 15.
The medium through which diffusion occurs is less concentrated.
Yeah, now you are reading now. Huh? You are waiting for the chance which I call. You all are reading now. You have to read, okay? That is the interest of the subject. You have to fight for the reading, okay? Then I will go to the next. Then once two substances diffuse from one place to the other, it may not interfere between two. Okay? It goes its own way, that goes its own way, because any particle, it has diffusion pressure, it moves. So it's only depend on its own concentration, not by the other. Example, gaseous exchange in plants, CO2 and oxygen. CO2 is taken place, oxygen is released. Okay, so what is a significance of diffusion? During photosynthesis and respiration, gas exchange is taking place due to diffusion. Okay, in photosynthesis and respiration, gases are exchanged. What are the gases exchanged in photosynthesis?
CO2 and oxygen.
Yeah. And what are the gases exchanged in respiration?
CO2 and oxygen.
Yeah, both are same. Okay, even some water molecules also moving here and there during the vapor portion and diffusion. Okay, so then somatal transpiration also taking place through the diffusion. Okay, and then the passive salt uptake, ions are absorbed by the process of diffusion. These are significant. Now I am going to teach osmosis. Can anyone read this osmosis definition?
The phenomenon of movement of diffusion of water molecules from the region of its high concentration to the region of its lower concentration through the semi-permeable membrane.
Yeah, then what is the difference between diffusion and osmosis? That is also from the high concentration to the lower concentration of water molecules. Here also high concentration to the lower concentration of water molecules. So what is the major difference between diffusion and osmosis?
Diffusion
Presence of semi-permeable.
Very good, very good. Very good. It's a presence of semi-permeable membrane. When the movements taken place through a semi-permeable membrane, that is called diffusion. Sorry, osmosis. If it does not have, this is diffusion. Okay, you can see the picture. There is a semi-permeable membrane. It's here. It's here. This cursor is not working. Wait. No problem. You are seeing now that osmosis. Okay, there is a semi-permeable membrane. There are high concentration of water molecules and less concentration of solids. So it moves from one place to the other. Then, like diffusion pressure, there is also osmotic pressure. The same phenomenon. The separation of two solutions by semi-permeable membrane, the pressure is developed in solution. Okay? There is a undissolved solution of particles or dissolved particles are there. Therefore, it needs water. So it has to come through a semi-permeable membrane. Then it is called, what is called osmotic pressure. The same kind of things, diffusion pressure, here osmotic pressure. Okay? What are the properties of osmotic pressure? So this osmotic pressure is generally measured with atmospheric units. Okay, bars. In bars, they generally measure. Okay, when the osmotic pressure increases means it is highly depend on the concentration of the solution of the solution. If the more concentration of the solution has high osmotic pressure, why? it needs more water molecule. So it pulls water molecules. Therefore, if this concentration is more, the osmotic pressure is high. So then, if a pure water is there, what is the osmotic pressure? Hello? If the concentration is more in the sort of water, we put sugar, and still, and then there is an osmotic potential develops. If no solution added, what is the osmotic potential of that particular vessel?
0.
Good. That is 0 because no solution. Once the solution increases, it is increasing. So always the solution has higher potential than pure solvent. Okay. If you are adding insoluble portions into the water, will the osmotic pressure increase? Hello?
No.
Why? There is no concentration difference. There is no addition of molecules because it is not dissolving. Okay? Good. Then we have few terminologies. Hypo, hyper, iso. Okay? Can anyone read this one? The first lesson. We will identify hypo, hyper, iso. What is hypo? Can anyone read this?
During osmosis, the movement of solvent molecules take place from the solution whose osmotic pressure is low
Okay.
into the solution whose osmotic pressure is higher.
Yeah. See, where the osmotic pressure is high, more solvent is available. Okay? Okay. Then, where the osmotic pressure is low, more water is available. So, if that particular concentration has more water, that solution is called hypotonic. Hypotonic. Okay? Okay. So if the water molecules are more in a solution than the more in the solution than other solution, the amount of water molecules is high, that is called hypotonic solution. But then the osmotic pressure will be quite low. In a hypotonic solution, osmotic pressure is low. In a hypertonic solution, osmotic pressure is, tell me,
High.
high. That means if the water molecules are more, that is hypotonic solution. If the solutes are more, that is hypertonic solution. There, the pressure, osmotic pressure is high. The hypotonic solution, osmotic pressure is low. Then isotonic means what? Both the places, the concentrations are similar. There is a continuous water movement, but there is no concentration difference. The water moves, here and there moves. Sometimes it stops, but both the concentrations are same. In that condition, we call isotonic solution or identical solution. Understand?
Yes, sir.
Yeah. Can you say what is hypotonic solution? Yeah. Low. It's low. But water is more. Okay, so we understood. We will go. So now what are the factors affecting osmotic pressure? As usual, concentration of a solution. If the concentration of the solution is high, osmotic pressure is also high. Okay? Then, if the ionization of the solute molecules are there, it also drags water. So if the ionization takes place in the solution, osmotic pressure also will be affected. Then as usual, temperature, if you increase the temperature, water will move from one place to the other. Then hydration of the solute molecules. If the soluble molecules are hydrated, that also making more osmotic pressure. Okay, now there is a diffusion pressure deficit, DPD. So here there is like osmotic pressure, there is a diffusion pressure. If the diffusion pressure is there due to a sucking force, that is called suction pressure. Generally, diffusion pressure synonym to the suction pressure. If there is a force of suction, the diffusion takes place. That's what the diffusion pressure is also called suction pressure. Okay? You can study later. Okay? This one. The force per unit area of entrance of water is termed as suction pressure. Pressure is always measured by force by area. Generally, what is pressure? Force by area. We say inverse parameter. So that is pressure. So if a unit area entrance, when we calculate that is called suction pressure. How much it goes through the unit area, that is suction pressure. Okay. So now cell is an osmoticum. So the osmoticum in the sense it acts as an osmotic place. In root hair, the topmost cell in the root hair. Can you try the white book? Where is this white book? No, when you stop here only white board will come. No problem. Okay, I will try. But this is also not coming a pen. Yeah, see, I will draw. No, it is also not coming. No problem. See, now a cell in a yesterday group 2 or 3 has put a picture of how the water enters into the root cell. The topmost portion of a root hair is a cell. It acts an osmotic system. When the water comes into contact with particular cell, the cells that has high osmotic potential, then water enters from soil to this cell, then it is called endoosmosis. That means water moves from outer environment to the cell, okay, through osmosis. That is called endoosmosis. Okay. Then turgor pressure and wall pressure. Can anyone read this? Please. Yeah, please. Read it. Of the wall. That is turgor pressure. Example, we are blowing the balloon. When you blow the balloon, simply it is there. There was zero pressure. But when you blow the balloon, that particular balloon itself swell, and it has some pressure. When you hold the balloon, the air will not go out. When you leave the hand, all the air will go out. Why? Because of the pressure exerted by the wall of the balloon. Like that, in a cell, when the water gets inside, it enlarges. When enlarge, the cell membrane has a pulling force. Again, it pulls, that is turgor pressure. Okay? So when it goes inside, that is turgor pressure. The particular turgor pressure, okay, to wall will exit another pressure, that is called wall pressure. So the water enters into the cell, it generates turgor pressure. The wall membrane exerts again, that is wall pressure. So now we are dealing with the diffusion pressure, osmotic pressure, turgor pressure, and wall pressure. That diffusion pressure deficient is called suction pressure. Okay? So these are the notes you can read it. So now we will come to the equation. In general, diffusion pressure deficit is related to osmotic pressure, turgor pressure, that means wall pressure. So the equation is diffusion pressure deficit is equal to osmotic pressure minus wall pressure. If the wall pressure and the osmotic pressures are same, there will not be diffusion pressure deficit. Okay? It may become zero now. See, OP minus WP. Osmotic pressure and W pressures are equal. OP minus W becomes zero. Then there will be no water movement. Okay? If the osmotic pressure is low, then the water pressure, it goes out. If the osmotic pressure is high, then the wall pressure, water enters inside. Okay? See, WP is turgor pressure, I have already told you. When the turgor pressure develops, wall pressure also increase. So in general, wall pressure and the turgor pressure are equal. Are you seeing the slide? Can you understand? See, wall pressure equals to always turgor pressure. Okay? But the suction pressure is P, becomes OP minus TP. Earlier formula, what was that? OP minus WP. That means wall pressure and turgor pressure are equal. If the fully turgid cell, there is no gap for the osmotic pressure. Once the osmotic pressure is there, water will definitely enter. If the OP and TP are same, there is no diffusion pressure deficit. The water will not come into the slides. Okay? If in the fully plasmolysed cell, what is the plasmolysation? Going outside the water from the cell. Then there will be OP, and this is equal to dPd, diffusion pressure deficit. See this cell. This is vacuole filled with water. So now here the cell is concentrated, water enters into the cell. Okay? Okay, this is in what solution? Hypotonic solution. If the outside hypotonic solution is there, it increases. If this is in hypertonic solution, okay, the water goes out. Here water goes in. So then when you read the slide, you can understand. Now we will see significance of osmosis in plants. We have already told you that, I have already told you the roots transportation from water through osmosis. There are two water absorption, active and passive. So both, they are that active against the osmosis, passive along the osmosis. There are osmosis is necessary when the water molecules are dissolved in the nutrients are dissolved in the water molecule, it comes. Then opening and closing of stomata, I have already told, that is, it is necessary for osmosis. Then turgidity of the cells, the shape and their organs are maintained due to osmosis. In general, the plants will die. When you put the water in, again, it comes to its forms, okay? Then there are few significance you can study. Now, imbibition. Okay, now we have studied diffusion and osmosis. What are the major four concentration of the solution? Can anyone say? Hypotonic, hypotonic, hypertonic, isotonic, or identical. Okay? Okay, so there is an equation dPd is equal to OP minus T2 or OP minus WB. You can read it. So now imbibition. So it is also diffusion. All three are diffusion. Diffusion, osmosis, and imbibition. It takes place from water higher concentration to the lower concentration. Here, can anyone see the definition read?
The movement of water from an area of higher potential to an area of lower potential without the assistance of a differential permeable membrane.
Yeah. So the water movement is coming from higher potential to a lower area without the assistance of semi-permeable membrane is called imbibition. Okay? So in general, the imbibition takes place due to the hydrophilic colloids. Okay? Hydrophilic colloids. So this terminology is must. The absorption of water by hydrophilic colloids is also known as imbibition. Okay? During imbibition, some energy is released. Have you noticed in the practical, in your daily event? Have you put cowpea or mungeta, that means mung bean, into water overnight? Have you done it in your home? Cowpea and then fire mungeta. When it happens, the morning when you touch, what you will feel? Two things will be observed. One, the size of the seeds has been increased, and there are some bubbles, and there is a slight increase in temperature. So the imbibition releases little portion of energy. Okay? So this you can study. When anything, here also see there is a pressure. If the pressure generated by imbibition is called as imbibitional pressure. Okay? Osmotic pressure, Jaeger pressure, wall pressure, diffusion pressure, deficit, and then imbibitional pressure. Okay? So now this is imbibitional pressure. You will see what are the characters. Very important roles that imbibition needs. When you put anything to germinate, first step, it takes water from the environment. If does not take, the imbibition is not taking place, germination will not be taking place. Some seeds, when you put into water, it splits. It splits its seed pod. Okay? Seed pods are split. Okay? Then in some rocky surface, when you put seeds, it will burst the rocks. It openly soil. That is also called imbibitional pressure. If the seed is sown in the land, it takes water and germinate. You will see it will lift the soil up and come out. That is imbibitional pressure. Okay? So certain seeds have more imbibition. Certain seeds are less imbibition. Okay? Proteinous seeds generally imbibe more water than the starchy seeds. Example, cowpea and soya beans and mung, green gram. It takes more water than the wheat or rice. Okay? So, as usual, here, imbibitional pressure, turgor pressure. Any water molecules goes inside the cell, that is called, that generates turgor pressure. Okay, here, if the imbibition has to be taken place, there should be the diffusion pressure deficit. If the imbibition pressure is more, only the water will go into the cell. Okay, so factors affecting imbibition, as usual, organic substances, temperature, pressure of solids, cohesion of molecules. Here the cohesion of molecule is necessary. Okay, type of solution. Significance of imbibition. We have already seen root hairs, we need imbibition, and everything we need imbibition. Now, plasmolysis. This is the coming out of water from the tissue. Tissue, water, the cellular water, coming out from the cell is called plasmolysis. So this is the, you can see this picture, hypertonic, isotonic, hypotonic. So I have already, when the water goes out, hypertonic solution. That means the cell wall concentration is higher than the outer concentration. That means outer concentration is less water molecule, hypertonic. Then water goes out. That is we call plasmolysis here. Okay. In isotonic, both ways it moves. Comes and goes, comes and goes. There is no static movement. It is a circular movement. Okay. This is we call flaccid. Then hypotonic, that means high concentration water, when you put the water get inside, then the cell becomes turgid. Okay, the cell becomes turgid. So these are very important terminologies. Hypertonic, plasmolysed. Isotonic, flaccid. Hypotonic, turgid. Okay, understand this picture? Hello? Have you understood this picture? Yeah, it is clearly, yeah, so six terminologies I used. Hypertonic, isotonic, hypotonic. If a hypertonic solution cell is plant, plasmolysis takes place. If isotonic solution, there is no change in the concentration, water comes and goes, it continuously happens. That is called flaccid cell. And then if the water concentration is higher, when you put a cell into that, that means in a hypertonic solution, the cell becomes turgid. Okay? So this is the plasmolysis. Initially, the protoplasm adheres with the cell. When the gradual decrease of water the protoplasm leaves from the cell wall. Have you noticed tamarind? Tamarind, bulliyange? How do you say? In single or tamarind? Can anyone say? Siambalam. Siambalam. Pudiyambalam. So when the tamarind is full, it is not mature, it may be like this. That is an example of turgid cell. When it matures, it comes from the outer shell and it becomes like this. Okay, this is plasmolized cell. Okay, this is an example of which it comes. It dries water, then comes from the cell like siambalam or priambalam or tamarind. That is a plasmolysis example. This is also things jam and the why in honey it may not destroy the honey. You can keep for a long time. How any bacteria or fungus, when it comes into the honey concentration, that means that is hypertonic solution honey. Okay, that means water is very less. Then the organic microorganism comes, it loses the water from its protoplasm. Then it dies. So nothing will damage the honey. Therefore, the same principle is used in jam and jelly also used, because any organs, when it comes, plasmolysis takes place. So how we can have deep plasmolysis? When again the loss turgid is increased by putting in hypotonic solution, the water will come inside, then it called deep plasmolysis. Okay? So what we have seen today, we will come by one. What we have seen today, okay, role and significance of water. Okay? Hello? Yeah, because 90% of the body part, it has all forms everywhere. The water is available. It takes place, it takes solution from one part to the other, one cell to the other, one tissue to the other, because it is a medium for the metabolic process, and it is a constitution of a metabolic. So water functions in very, very, it gives the turgidity of the cell and very big role. And we have seen the nature of cellular water. In cellular water, in generally, it is hypertonic solution. It has some this osmotic pressure or diffusion pressure. There are four. We have seen diffusion, osmosis, imbibition, and plasmolysis. We have seen plasmolysis coming out the water. These all three are getting inside the water. Diffusion first we have seen, and then what are the causes to increase the diffusion process. And when two particles moving from here and there is more interference between these two particles, that is independent diffusion process and the significance. And then we have studied osmosis. What is osmosis? And then what is osmotic pressure and property of osmotic pressure. We have seen some hypoisotonic solution, and what are the factors affecting osmotic pressure and the DPD we have seen, and we have seen an equation and where how it behaves, and where the turgid pressure and wall pressure becomes important part in the diffusion pressure deficit. And then osmosis, what are the significance of osmosis, and imbibition, what is taking place. It is also movement of water, but not without the help of the semi-permeable membrane. There is a imbibition pressure also we have seen. We have seen equation of DPD and factors affecting imbibition and significance of evaporation and plasmolysis. And finally, we have seen 6 different terminologies in all these three: hypotonic, isotonic, hypotonic, plasmolysed, flaccid, turgid. So all these become very important in your examination point and in knowledge point, that these are very much important factors. So finally, we have seen how the examples of tamarin for the plasmolysed cell, how it comes from the shell when the water dries. So same example we have seen for the plasmolysed cell also. Then what is the advantage of plasmolysis? We say the technology is used for jam and jelly. Okay, then once the cell is plasmolysis, once you put into a hypotonic solution, it becomes deep plasmolysis. That means we are giving the water back into the cell. Okay, since the section is more, I was rushing. I think you could have understand my lectures. Okay, can we? Yeah, I will come to the stop sharing. Okay, are you clear? What are the processes we have seen today?
Yes, sir.
What we have seen today? What are the process? 4 major processes. What we have seen? Tell me.
Osmosis, diffusion,
Fusion, division.
Diffusion, osmosis, then
imbibition,
imbibition, then plasmolysis. Okay, so what is the concentration difference solution? Hypotonic,
Hypertonic.
isotonic.
isotonic. So what will happen if the hypotonic solution, the cell is put into hypotonic solution? The osmosis take place because of the osmotic pressure. So now are you clear enough?
Yes,
Are you
sir.
clear? Yeah, you have done practicals. Okay, the sums and all you have done practical by our demonstrator. Okay, so with this, shall I conclude this lecture? Yeah, I have covered the prescribed portions for me. Transpiration, water relation ascent of sap. Okay, then photorespiration, respiration, and then today water relations. Okay, this is water relations 2. That is water relations 1. Understood? Okay, so I will send you the feedback form through LMS. You can fill and send it to me. Okay, through the mod, what they intended for that. Okay, so then now it's 10 o'clock. So you have any other class by 10?
Yes.
Okay.
Yeah. Yeah, then you can have a good day today, study hard, and none of you should not get below 90. You have to study hard. You must get A+. Okay, I always say, and I have given maximum information in the portions what I have intended to you. Then you have to collect notes and study hard and then perform well. All the best. Thank you. Okay.